So Europa is one of the 4 major moons of Jupiter. It's about the same size as our own moon, but it looks very different. It's got a smooth, bright, white surface covered in these dark cracks and red patches. The reason for that, and what makes Europa so incredibly interesting, is that it's thought to be engulfed by a global ocean under a thick crust of ice. In fact, it's got twice as much ocean as planet Earth. If we have a salty ocean in contact with a rocky core and energy from a variety of sources, as we just heard from Mary, we have many of the ingredients thought to be necessary for life. In 2014, we used the Hubble and detected evidence of what are probably water vapor plumes emerging from the surface of Europa. That's important because it could be giving us access to subsurface liquid water without having to drill through miles of ice. In 2016, the new observations that we're just publishing, we saw a similar candidate, almost identical in appearance and at the identical location to one of the 2014 candidates. It's very important in an intermittent phenomenon to establish repeatability. It gives us a lot more faith in the observation. The other thing it allows us to do, given the position of Europa, given the position of the candidate on Europa, is to look with more fidelity at that position and see what else we can find there. If we just look at a map of Europa, we don't see anything particularly remarkable at the exact location of the plume candidate shown by the green ellipse. But if we look back to the Galileo data, Galileo in the 1990s published a thermal image, and right at the peak of the thermal image, that's where the plume candidate is. This hot spot on the surface of Europa, on the Europa night side, was identified at the time as a thermal anomaly, and it's sitting right on top of the position of our plume candidate. It's really intriguing. It was quite astonishing, in fact, just to see the coincidence of the two. But it wasn't an accident that we looked for the thermal imaging. We did it by analogy with Enceladus, as we all know, as you know, and the other people here know. The plumes of Enceladus are associated with a heat source and its very distinctive signature. And so we looked to see if we could find thermal imaging of the surface of Europa, and we did. And the peak hottest point in the Europa night side was right where our plume candidate is. There's two possible explanations for a causal connection. Obviously coincidences could just occur, but there are reasons to think there could be a causal relationship. One possibility is if there's liquid water at a depth below the ice surface, and the liquid water is obviously warmer than the surface. The heat can flow up through the ice and cause a thermal anomaly, and cracks in the ice could give us the plumes. Conversely, the plumes themselves could simply be venting water vapor high into space from the Europa surface. We see plumes rising to 100 kilometers, 60 miles, and we would expect the water vapor to spread out over a much bigger area than that. We're not at escape velocity, so it's got to come back down. If a fine mist of water vapor rains back down onto the surface, then it can change the thermal character of that surface and allow it to retain heat longer. And so instead of heat coming up from below, it could be heat from above being slowly re-radiated during the Europa nighttime. And so it's a very intriguing pair of results. We discovered a repeating plume candidate, and when we looked at the Galileo data, we found the position of that repeating plume candidate was right at the position of a thermal anomaly. We look forward to the Europa Clipper mission, which Jim is going to tell us about, and that will characterize this and other areas in great detail. We looked 12 times, and we saw it twice in that location. We did see some evidence of plumes around the South Pole, polar regions a couple of times too, but it's much harder to locate the source when you're down at the polar region, and there isn't any coverage by Galileo in that region either, so we were lucky to find this one that did repeat was actually near the equator, and so it was twice out of 12 times, 1 in 6. The statistics tell us that just from random photon statistics, they're real. They're what we call 4 sigma results. Now that's not quite as strong evidence as you'd really like. You'd prefer it to be stronger than that, because at that level there's always the possibility that there's some sort of instrumental effect that you don't know about. We've covered ourselves in terms of trying to understand what possible instrumental effects could have caused this, and every single one that we can think of does not appear to be capable of doing it. And so, for example, the two observations that I showed, although they look the same in the same position when we project them on the sky, when they were taken with the camera, the Hubble was in a completely different orientation for those two images, and so they're in completely different parts of the camera with the telescope rolled around at a completely different angle, and that eliminates a whole bunch of potential systematics that could cause it. So from the Hubble perspective, we're I wouldn't say it's not completely unequivocal the way it is with Enceladus. We're still at the limits of what Hubble can do, but we're growing in confidence because of the repeat and because of, in my case at least, with I find the correlation with the Galileo thermal data quite intriguing and quite compelling. It's not completely unequivocal, but in my mind the pendulum has swung from caution to optimism. The evidence is growing. The fact that we saw a repeat at the exact same location, that's one of the gold standards for dealing with an intermittent phenomenon. It's not proof because we're right at the limit of what the Hubble can do. It's not completely unequivocal the way it is on Enceladus. So on Enceladus you've got movies of the plumes, and you've got wonderful maps and temperature maps and mass spectrometer measurements of the composition, and we've got a little smudge next to an image from the Hubble, and you know, it's a fantastic image, and but it's right at the limit of what the Hubble can do. The fact that we've got a repeat tells you that in a formal statistical sense it can't happen by chance. So we have to look for systematic effects that might cause it. We don't know of any, which is why some of us are leaning towards thinking that this means they're real. And then the secondary information with the thermal imaging, since I went to look for the thermal imaging, that gives you some additional statistical evidence that in fact they're real. It doesn't prove it because, you know, unfortunate coincidences can happen in the world. In terms of the location, the original detection by the Roth team was around the South Polar region. These are the dissociation products of water at high altitude down around the South Pole. And in our transit observations, where we were looking for absorbing material around Europa, we did see a couple of features in that area, but it's harder to localize things around the poles. This particular one was well localized. It wasn't quite as high as the previous one, and that's the one that repeated, and so that's really quite interesting. I think the short answer is we don't know. There are suspicions that they're salts from the ocean, but it's not known what sort of salts, and that potentially there's a contribution from the Jovian magnetosphere of sulfur ions being implanted from Io, the next moon in, that's definitely got plumes. It's got sulfur volcanoes spraying sulfur into the whole environment. But the detailed composition of the cracks and the dark areas, it's an ongoing study of research. People are trying to find out. It's obviously a very interesting question, and it will be very nice to know the answer to that.